For decades, we have been told the same message again and again. The planet is heating up, ice is melting, disasters are increasing, and unless we act immediately, humanity is at risk. But here is a simple question that almost nobody asks properly. Is climate change purely a scientific issue, or has it also become a political and economic narrative that goes far beyond what the data alone can tell us? In this video, I am not denying science, and I am not repeating slogans either. I am going to slow down, look at actual measurements, and separating what is observed from how it is often presented. Originally, the term most commonly used was global warming. The idea was straightforward: greenhouse gases trap the heat, and the average temperature of Earth increases. Direct measurements show that global average surface temperature has increased by about 13 degrees Celsius compared to the period between 1850 and 1900, according to multiple independent data sets used by national scientific institutions. However, scientists realize that temperature alone does not explain what people experience locally. Some regions see heavier rainfall, some experience longer droughts, and some even face colder winters despite global averages rising. Because of this complexity, scientific institutions began using the broader term climate change, which includes temperature, rainfall, winds, ice behavior, and ocean changes. At the same time, the phrase global warming became politically sensitive. Communication advisors argued that climate change sounded broader and less confrontational. So the shift was not purely scientific and not purely political, it was a combination of both. Multiple independent data sets measuring Earth's surface temperature show a clear long term warming trend since the late 19th century. According to records maintained by national meteorological and space agencies, the last decade has consistently been the warmest since modern measurements began. However, this warming is not uniform. Land areas have warmed faster than oceans, polar regions have warmed faster than the global average, and some regions show stronger trends than others. This uneven pattern is well documented and is often one of the reasons scientists caution against using temperature alone to explain all climate related impacts. One of the most reliable data sets in climate science is atmospheric carbon dioxide. Now, carbon dioxide has been directly measured since 1958 when concentrations were around 315 parts per million. By 2024, these measurements crossed 420 parts per million, an increase of more than 100 parts per million in just over 6 decades. These measurements were confirmed independently by ground stations and satellites. This does not automatically mean a catastrophe, but it does mean that the chemical composition of the atmosphere has changed rapidly compared to natural variations observed in geological records. And now, here is the science that is observational and direct. The debate begins when we move from measurement to long term predictions. Satellites that measure changes in Earth's gravity field show that Greenland has been losing on an average of roughly 260 gigatons of ice per year since the early 2000s. However, this loss varies significantly from year to year depending on snowfall and melting of ice during summer. Antarctica presents a more complex picture. West Antarctica and the Antarctica Peninsula are losing ice, while parts of East Antarctica show periods of snowfall gain that partially offset losses. When averaged together, Antarctica shows a net loss but with strong regional differences. And most excess heat from global warming does not remain in the air, it gets absorbed by the oceans. Measurements of ocean heat content shows a steady increase, contributing to global sea level rise of roughly 3 millimeters per year since the early 1990s. This rise occurs even without dramatic ice collapse because warmer water expands. So, yes, ice and oceans are changing, but not in a single simple collapse driven way. When you look at how developed and developing countries are coping with climate change, this is where climate science intersects with geopolitics. Historically, industrialized countries contributed most to the greenhouse emissions. Scientific studies estimate that developed countries are responsible for roughly 60 to 80% of cumulative emissions up to mid 2000s. At the same time, many developing countries contributed far less but face higher vulnerabilities due to climate impacts. This imbalance is acknowledged in international climate agreements. However, policy implementation tells a more complicated story. Developing countries are often asked to limit emissions, growth, or change energy systems earlier in their development journey. Meanwhile, developed countries increasingly rely on carbon emission trading, also called as Carbon markets. In simple terms, governments set a limit on how much carbon dioxide can be emitted. This limit is divided into permits, often called carbon credits. If a company or country emits less than it is allowed amount, it can sell the unused credits. If it emits more, it can buy credits from others. In international carbon markets, this often means an emission reduction project in developing countries is counted towards the target of a developed country. On paper, global emissions remain unchanged. In practice, responsibility shifted geographically. And according to World Bank assessments, this system does not necessarily reduce total global emissions. It mainly redistributes where the reduction occurs. This is why climate policy can feel uneven even when the underlying climate science is real. So, if you look at climate models, they are computer simulations used to understand how greenhouse gases affect Earth's energy balance. They perform well when reproducing long term temperature trends. But significant uncertainties remain. Cloud behavior is one of the largest sources of uncertainty. Cloud effects can either amplify or reduce warming, and this uncertainty is larger than the direct warming effect of carbon dioxide in some cases. Another key uncertainty is climate sensitivity, which estimates how much warming occurs when carbon dioxide levels double. Despite decades of research, estimates still range between 2 and 4.5 degrees Celsius, a spread large enough to influence policy decisions significantly. Climate models are tools for exploring scenarios, not precise forecast of the future. Today, climate change is no longer just a scientific topic. It is connected to energy, policy, economic power, international finance, and global influence. This creates two extremes. One side treats every question as denial, and the other side treats every policy as manipulation. Both shut down meaningful discussion. So, science progresses through evidence, uncertainty, and revision, and not through slogans. So, climate change is real, human activity does play a role in it, and the planet is warming. But the scale, speed, regional impact, and policy responses involved uncertainty that is often ignored in public messaging. The real danger is not questioning science, the real danger is turning science into ideology. And once that happens, trust collapses on all the sides. That's all for this video. If you liked it, please like, share, and subscribe for more such explanatory videos.